All right, guys, I'm about to go over this review. Let's see. Here we go. All right. So this first problem, sorry, let me pull up, is use substitution because we have an inside part. So we have to go ahead and set u equal to our inside, get our derivative, which was just 3. Dx equals du over 3. So now if you notice here, since it's on the bottom, let's just bring it to the top. So here I'll make this u to the negative 1/2 power, because it's really square root of u in the denominator. I'll just bring it back up. And the dx on top, I'll just put on the side, which is du over 3. And if we convert our bounds to u values, this will just become 16. This will become 1. So now all we have to do is just solve this antiderivative. I'll rewrite it to make it look a little better. 1/3 u to the negative 1/2 du, 16 and 1. So now we take the antiderivative of this, so add 1 and divide. So that becomes u to the 1/2. If we add 1 to that, divided by that, it becomes 2. So 2 times 1/3 is just 2/3. We don't need a plus c because we have bounds. And then we can go straight from here, which would end up being, sorry, 2/3, 16 to the 1/2 power, minus 2/3, 1 to the 1/2 power. Now we do have to simplify this since it's multiple choice. We have to see which answer this ends up being. So remember, 1/2 power just means square root. So we end up getting the square root of 16, which is 4, times 2/3, which is, sorry, let me go here. 8/3 minus square root of 1, just 1, so minus 2/3. We end up with 6/3, which equals 2. And again, if you didn't want to change your bounds to u, you could have left them 5 and 0. You would just have to go back to our whatever our u is equal to, in this case 3x plus 1. And then you could use 5 and 0, and you would get the same answer. All right, now our second one was a Riemann sum, a right Riemann sum. It gave you the intervals. So we had 3 rectangles from 2 to 5, that's a width of 3. From 5 to 10, that's a width of 5. And 10 to 14, that's a width of 4. Since it's the right Riemann, they want our right heights, which is our y values on the right side. So it would be the y value at 5, which is 28. Y value at 10, which is 34. The y value at 14, which is 30. And now we just do the area of the rectangle, length times width, base times height, however you want to think about it. 28 times 3 plus, this is times 34 times 5 plus 30 times 4. So do this by hand. Here, I'll do this real fast. What is that? 84 plus 50, 170 plus 120. So add those together, and we end up with 270, 290. 290 plus 84 is 270, 374. There you're at. Our next problem is the left Riemann sum. So it's pretty similar. So here we have 3 rectangles width of 3, width of 2, width of 1, left Riemann sum, that's our left heights, 10, 30, and 40. 10 times 3 plus 30 times 2 plus 40 times 1, which is 30 plus 60 plus 40, which is 130. All right, next problem. Here again we have an integral. Here we don't have any bounds, so they're just looking for an equation plus c. So we got to figure out what to do. This is not a basic problem where we do have an inside, so we have to do u sub. Here, our u would be our inside part, 3x squared plus 5. Our derivative would be 6x. So our dx is equal to, dx is equal to du over 6x. And now let's see what will happen. We end up with x. Let's bring that square root to the top, so it would be square root of u, but we'd bring it to the top, so we'd make it to the 1/2 power and have to make it negative because we're bringing it to the top. And dx is equal to du over 6x. All right, cool. The x's cancel out. So now we're just really left with 1/6 u to the negative 1/2 du. So what does that equal? Add 1 and divide, and we end up with u to the 1/2 times 2. So that would be, or divided by 1/2 means times 2. So 2 times 1/6 is 2/6, or 1/3, plus c, because there's no bounds to plug in. So now we just have to plug in our u. So let's simplify that to 1/3. 3x squared plus 5 to the 1/2 power plus c. Let's see here. Do we have that? Yep, that's answer choice D. As we get to the second page now, here, this one looks a little confusing because automatically this looks like a u, because it looks like we have an inside part, but we don't really have an inside part. And for multiplying, sometimes we can still use u sub, but in this case, if we pick our parentheses set to be u, our derivative would be (3x squared) and now we kind of be stuck because this x cubed doesn't cancel out with this x squared. You could, and we'd still have x left, and then it would become a lot more complicated than we need it to be. So a thing to notice is we don't necessarily always have to just go straight to u sub. In this case, we could simplify this to make it a lot more basic if we just distribute the x cubed. So if x cubed times x cubed ends up being x to the 6th, remember we just add our exponents when we multiply x's, minus 2x cubed. All I did was just distribute that dx. I'll put in parentheses because that dx goes to that whole thing. So now it's basic. This is going back to a basic antiderivative problem. All we have to do is add 1 and divide. X to the 7th divided by 7 minus x to the 4th divided by 4. So that's just 2/4 plus c. So let's see. Out of our choices, so sometimes they make it look a little annoying, so we can see which one looks like us. Look at the exponents and go from there. We want x to the 7th power here. Is that the same thing? X to the 4th over 2. Yeah, because this simplifies to 1 over 2. So A is our answer in this case. Part B, if you multiply this out, this would be x to the 8th power. We don't have anything to do with that. Here, this would end up being x to the 6th. We're looking for x to the 7th. Same thing, so kind of use that as also as a guide. This next problem, this one was a little tricky because it gave you this equation, but then it wants you to figure out f of 4, and they give you f prime. So yeah, we know we're gonna have to do the antiderivative work backwards. So you could just find the antiderivative, then figure out what plus c is from here, or you could set up a definite integral like we did before with the fundamental theorem of calculus. So what I mean by that is we set up starting point 1 to 4 of our, if we take the antiderivative of this, remember, it'll go back to the original f, plug in the top, minus plug in the bottom. We did a lot of this with area. So it's the same concept. So now if we figure, we know that this is what they're asking for. They give us this as 0. So now we just have to figure out what this area is from 1 to 4 underneath the derivative, or by doing the antiderivative, by doing what we've been doing right now. Do we have to do u sub? No. Technically, because if you think about it, there's no way to really cancel out this x and go from there. So what we have to do is split this up into 2 fractions. So what I mean by that, it'll be break up the numerator. This is just a square root of x, but I just wrote it as the 1/2 power. So you could think about it like that and then do it, or you could bring up the x to the negative 1/2 and then distribute it. Either way works. From 1 to 4. All right, so let's simplify this to make it basic. This ends up being, remember when you're dividing x's, you subtract your exponents. 1 minus 1/2 becomes 1/2 plus x to the negative 1/2. All right. See, we didn't even use u sub at all. Now it's a basic problem. Now all we have to do is add 1 and divide. Add 1 and divide. Plug in 4 and 1. Remember, we're not dealing with u at all. We didn't have to do any of that. So here we end up getting 2/3, 4 to the 3/2 plus 2, 4 to the 1/2 minus, do it again, but now with 1. All right, so now we got to actually simplify it since it's multiple choice, but we're also not done. We have to figure out what this is. All right, so here, 4 to the 3/2, how do we do that? Like I was saying earlier, that I just do the bottom of the fraction on the exponent first. That just means the root. So this is a square root. Square root of 4 is 2 to the 3rd power. What is that, 8? So that becomes, this is 8 because the square root of 4 is 2. Then 2 to the 3rd power is 8 times 2/3, which is 16 over 3. The square root of 4 is 2 plus 4 minus 1 to the anything is just 1, so that's 2/3. 1 square root of 1 is 1, so that's 2. All right. So now let's just simplify this by adding these fractions. 4, that's the same thing as saying 12 over 3. So 16/3 plus 12 over 3 is 28 over 3. Minus, here, this is 2/3, make this 6 over 3. So let's do this first. So that's 8/3. So subtract that, 28 over 3 minus 8 over 3, and we end up getting 20 over 3 right here. And the reason why, because we were minusing 0. If this was a regular number, we'd have to add it to that. But now, this is basically my question mark. So this is the area from 1 to 4, which also happened to be f of 4 in this specific case, because we were minusing 0. Our next problem, so you have to look at this. Do we have to do u sub? Yes, because we have an inside. If it was just sine of x, then no. But since it's sine of something else other than just x, it's just like chain rule. So our u would be 3x plus 4. Our derivative is 3, and dx is 4. So even though there's no x or anything to cancel out on the outside, this part matters because of this dividing by 3. So now I end up having sine u du over 3. So now this is basic because it's just sine of some variable. It's not sine of more than a variable. This is just sine of u. So let's bring that 3 up into the front because we're still dividing by 3. It didn't cancel out. And now take the antiderivative of sine, which is negative cosine. That 1/3 just stays the same. It's a coefficient. Plus c. Now we just got to plug in our u, which is 3x plus 4, and go from there. And look, they have answers that are very similar if you forgot the negative or if you forgot that 1/3. It's right there or right here. So be careful. Next problem. Here, like I said, I like to consider it on a number line. The area from 2 to 8 is negative 10. The area from 2 to 4 is 6. So what's the area from 4 to 8? So 6 plus this area has to be the total area, which is negative 10. Don't worry about the negative. It just means that this area it's below the x-axis when you're talking about area. So 6 plus some number will be negative 10. So that must mean this is a big negative number, which is negative 16. And we're going forward all the time, so we didn't have to worry about changing the sign or messing with anything. All right. So here, I see people want to use u sub for this too. This is already basic. This is just 2x to the third power. You see how it's just x to an exponent? If it was in parentheses where you had x plus 5 to, or x plus some number to an exponent, then yeah, we do. But this is just x. So we don't have to do u sub at all. Add 1 and divide. We end up with x to the 4th, divide by 4. Take the antiderivative of 3. That's just 3x. All right, cool. Plug in 2 and 0. So that's just 1/2 2 to the 4th power plus 3 times 2 minus 1/2 0 to the 4th power plus 3 times 0. So this just ends up being 0, so we don't have to worry about that. Here, let's see, what's 2 to the 4th power? 2 squared is 4, 8, 16. 16 divided by 2 is 8, plus 6. There we have it. Here, they want the area from negative 2 to 4. There's no equation, but there's the graph. All right, cool. From negative 2 to 4 going forward, so we don't have to change the sign. Here, we have this quarter circle. Here we have this triangle. It's negative because it's below the x-axis. And then we have this triangle right here. All right, so let's do the quarter circle. That's pi r squared, which is, my r is 2. So that would be r pi 2 squared, which is 4 pi divided by 4. I divided by 4 because it's just a quarter, a fourth of a circle. Plus this triangle. So that's base times height divided by 2. 1, 2, 3. Times my height, which is 1, 2. So 3 times 2 is 6. Divided by 2 is 3. And I know it's negative 3 because it's below the x-axis. Plus this triangle. 1 times 2 is 2. Divided by 2 is 1. And it's positive because it's above. All right. So what is equal? Pi minus 2. All right. Find the particular solution. So remember, that's going back to basic antiderivatives before we got all complicated. It just wants us to figure out what the C is based off this. So We'll take the antiderivative of our f prime, which is 4x to the negative 1/2 power. So what does that equal? That would be add 1 and divide. Plus c. All right. So now what this tells us, this will help us find c when we do 12 equals 8, plug in 1, plus c. What does that equal? 1, 8, c equals 4. Because we minus 8, because this just ends up being 1 times 8 is 8. Move that over, 4. All right. So my final answer would be and you can put it as a square root if you want. So remember, particular solution just means it wants you to find f of x and also find c. So they want our equation for f of x with the c value. All right. Here, they give us another area problem. The area from 2 to 5 is 6. The area from 0 to 5, so that's his whole area, is 2. What's the area from 2 to 0? All right, so they want this area, but notice that they were going backwards because this 2 is at the bottom. So we're going to find this number like normal, but then we'll just go backwards by changing the sign. So don't think about it yet until we figure it out. So this area plus 6 equals 2 would be the whole area. So this has to be negative because obviously this is smaller. So this would end up being negative 4. 6 plus negative 4, that would give me my whole area, which is 2. But since this is going backwards, they would want us to change the sign. So my area is 4 from what they're asking. If they were asking just the area from 0 to 2, it would be negative 4. But since we're going backwards, they want us to change the sign. All right. Here you have a word problem with a situation. They give you the rate, and they're asking how much was added. So it's not asking how much was in the pool. It is how much went into the pool, how much was added in the first 4 minutes. That's key. First 4 minutes, that means from 0 to 4. How do I know I'm going to do an antiderivative? It's because I'm given a rate, and they want to know how much gold. So that's pretty much going backwards into it. And integrals give you the total amount of anything from our start to our end. So here we have it. Now all we have to do is add 1 and divide. We don't have to worry about U sub or anything. It's a basic problem. There's no inside. There's not anything crazy happening. Add 1 and divide. End up with t cubed. Add 1 and divide. T squared, because you divide. That cancels out the coefficients. Dividing by 3, cancel this out. Dividing by 2, cancel that out. Plus c, but we don't need a plus c because we have bounds. So plug that in. 4 cubed plus 4 squared minus 0 cubed plus 0 squared, which is just 0, so I don't have to worry about that. So 4 cubed, what is it? 4 times 4, 16, times another 4, 64. Sorry. Plus 4 squared is 16. So just 64 plus 16. What is that? That is 74, 80. But let's put our units. What's gold measured in? Gallons. All right. So we had 80 gallons that were added into the pool. Now how much gold was inside the pool after that 4 minutes? So basically it's saying after this was added to it, how much total is in the pool now? Well, let's see, the pool already had 20 gallons into it. So it would just be 80 plus our initial amount was 20. So that would be 100 gallons. All right. Our next problem wants us to use a Riemann sum from 0 to 24 for subdivisions of equal length. So that just means we're going to divide this up into 4 sections. So if you think about it, how do I figure out what am I going to skip by? 0 to 24 divided by 4 would end up being 6. So here's one. There. So we have 4 rectangles. They're all equal. So 0 to 6, I'll write them out to make it a little easier to see. 6 to 12, 12 to 18, 18 to 24. See, what it means equal is that they're all 6 wide. Now, are we doing the left side or right side? What is it asking for us to do? The midpoint. Okay, so the number right in the middle. So it wants us to use a y value that's right in the middle. So that would be, in this case, the y value at 3, 10.4. Oh, man. It's going to mess up. All right, sorry. Let me just restart this real fast. Sorry. All right, so like I said, this was 0 to 6, which was 3. Sorry. 0 to 6. I'm tripping. There's 6. These are all 6. So the midpoint right here was at 3. That was 10.5 or 10.4. This midpoint right here is at 9 from between 6 and 12 is 9. That's 11.2. This midpoint is 15, which is 11.3. And the last midpoint is 21, which is 10.2. All right, so there we have it. 6 times 10.4, or let me put in parentheses so that doesn't get confused as a decimal, plus 6 times 11.2 plus 6 times 11.3 plus 6 times 10.2. There you have it. I'm not going to bother simplifying it. Remember, this is not a multiple choice question now, so I don't need to worry about it. Let me put my units. So this would be hours times gallons per hour. The hours would just cancel out, and this would be gallons. Oh, and then it says using correct units, explain the meaning of your answer in terms. So this represents how much the water level changed. In gallons. Another way of saying this is the total amount of water that came out of a pipe. I would also mention the time from 0 to 24 hours. Yeah, that's including everything. So that's how much the water level changed by this much. Or water level came out of the pipe. Here, so again, now we're multiplying. We could try u sub, but if we think about it, if we pick cosine to be u, our derivative would be sine x. That wouldn't cancel this out. If we pick tangent to be our u, our derivative would be secant squared. That wouldn't cancel this out. So what can we do? Let's try to simplify this down. Anytime that I have stuff, I try to convert it just to sine and cosine. So we know tangent means sine over cosine x. Look at that. That made that a lot easier. So antiderivative of sine, negative cosine x plus c. And it was that simple. Next one, add 1 and divide. We don't need a plus c because we have bounds. Plug them in. Go from there. And here I won't simplify it because I don't have to, but if you wanted to, that was 8. 32 over 3 minus 4/3, which would be 32 minus 4, which would be 28 over 3. Here, we do have to do u sub because we have x over 3 inside. If it was just sine x, would be good, but this is sine of, it's not just x. So here, we got to do u sub where u would be x over 3. My derivative would end up being 1/3, because if you're not sure, this is the same thing as this. So my derivative is just that, dx cross multiply. If you do du divided by 1/3, you can, but it just ends up being 3. You know, when you divide by a fraction, it just means flip it. All right, so now I end up with sine u times 3 du. So I'll just put the 3 in front. Here, you could either convert these to u's. So if I wanted to do that, that would just be 0 divided by 3. In this case, this would be pi over 2 divided by 3, or just 1/3 times pi over 2, which would end up being pi over 6. Take the antiderivative of that. 3 cosine negative cosine u plus c, but I don't need my plus c because I have bounds. So here, I'm going to leave it in terms of u because I converted these to u's. If you wanted to, you could convert this back to x over 3 and then use those bounds. Either way, you'll get the same answer. There you have it. Then our very last problem. So now we have tan squared and secant squared. So in this case, we can use u sub because if you think about it, if we pick u to be tangent x, our derivative is secant squared, and that's going to cancel this out. So we end up with u squared. You notice I didn't put the squared part in here, so I just left it here. Now the secant squared x dx over, or sorry, dx is du over secant squared. That cancels out. So now I'm just left with u squared du. So I don't even have any trig problem in this section once I made it basic. Add 1 and divide. End up getting 1/3 u cubed plus c, because I don't have any bounds, I need my plus c. Then I just plug it in at the very end. So 1/3 tangent x to the 3rd power plus c. There's my answer. So that's it.